Hey everyone, and welcome to this explainer. Today, we're unpacking what honestly might be the greatest underdog story in modern computing. If you've been around software development over the last decade or so, you've probably heard people say XML is a total relic, just completely replaced by newer, flashier formats. But the truth? It's kind of wild. XML is actually this invisible, armored infrastructure quietly powering the absolute most critical systems on the web. It is literally the secret bridge of the internet. To really understand why, we've got to start with a bit of a high-stakes mystery. Think about the massive global digital economy for a second. On one side, you might have a 20-year-old banking mainframe running legacy code, probably held together by duct tape and prayers, right? And then on the other side, a hyper-modern, super agile cloud app running on a completely different operating system. So how do these vastly different computing architectures actually communicate? Seriously, how do they speak the exact same language without completely garbling the translation? Okay, let's dive into this. Here is our clear roadmap for solving the mystery today. First up, the enterprise integration mystery. Then, JSON, the lightweight speedster. Third, XML, the structured heavyweight. Fourth, strict schemas and data integrity. And finally, number 5, the universal enterprise bridge. Let's jump right into Section 1, the enterprise integration mystery. We need to establish the baseline friction that software engineers are dealing with basically every single day. In the enterprise world, you are almost never working with a perfectly uniform tech stack. You're dealing with what we call heterogeneous systems. Imagine, say, an inventory system running on Linux and written in C++, and it's trying to send shipping data over to an accounting system that's running on Windows and written in Java, and oh yeah, they're pulling from completely divergent underlying database structures. Without a standardized format to act as a go-between, these systems literally cannot serialize data or exchange information safely across a network. It'd be exactly like two people who speak completely different languages trying to hash out a highly complex legal contract without a translator. Just a total mess. Moving right along to Section 2, JSON, the lightweight speedster. Now, before we talk about our heavyweight champion, we definitely have to acknowledge the current reigning king of modern web apps. If enterprise data exchange is a giant logistics network, JSON is basically the swift courier zipping around on a motorcycle. JSON stands for JavaScript Object Notation. It's a highly compact, purely text-based format that organizes data into really clean, human-readable property value pairs. And because it relies on such simple structural layouts, it has become the absolute go-to standard for agile web development and dynamic cloud apps. When you dig into it, developers absolutely love JSON. And the reasons are brilliantly simple. First off, it lacks all that heavy text overhead. This drastically minimizes network bandwidth consumption, which means faster page loads for the user and way lower server costs for the business. A real win-win. But its real superpower? It maps directly to standard object-oriented programming memory models. When you pull a JSON payload into a Java or Python app, it natively translates right into objects and arrays. It even has native array support straight out of the box, completely eliminating the drag of complex data translation layers. It's fast, it's lean, and it's incredibly agile. All right, on to Section 3, XML, the structured heavyweight. So what happens when you aren't just sending a quick status update to a web browser? What happens when you are moving, say, millions of dollars in financial transactions between massive, heavily regulated databases? Well, that's when you call in the Armored Transport Vehicle, XML. XML, or Extensible Markup Language, is a non-relational, hierarchical metalanguage. It was designed specifically to represent data as a perfectly well-formed parent-child tree structure. Unlike HTML, which uses fixed, predefined tags just to tell a browser how to display things, XML focuses strictly on what the data actually is. It lets developers define custom, self-descriptive tags to represent really complex, deeply nested data structures. Now, what's really interesting about this slide is the stark contrast in how these two formats consume resources. JSON wins entirely on minimal syntax and low network bandwidth. XML, on the other hand, really suffers from high text verbosity. Because every single element in XML requires both an opening and a closing tag, like you literally have to write an opening account tag and then a closing account tag, the file sizes get significantly larger. Plus, navigating that XML tree structure programmatically usually requires what's called a DOM parser. That means the system has to load the entire file into memory at once before it can read even a single line. And as you can guess, this creates a massive parsing memory overhead when you're handling large data sets. Setting their internal mechanics side by side reveals exactly how they differ structurally. JSON gives you that native array support and frictionless mapping we just talked about. XML strangely enough, actually lacks built-in support for arrays. This means you have to write repetitive element blocks over and over again, which kind of complicates the processing side of things. But here is the catch. Where XML loses in agility, it unequivocally wins in hierarchical rigor. It gives you this incredibly strict, multi-layered tree structure that easily models complex, semi-structured data relationships. Trying to do that exact same modeling in a traditional relational database would require a dizzying and super fragile web of connected tables.
Which brings us to Section 4, strict schemas and data integrity.
And this brilliantly illustrates our next major point. Why on earth would enterprise systems willingly pay the heavy bandwidth and memory penalty of XML? Well, it all comes down to strict schemas. Think of this process in 4 steps. Step 1. The data payload arrives at the receiving server, but before the application code even gets to touch it, Step 2 kicks in. The data is intercepted by external schemas, specifically document type definitions, or DTDs, and XML schema definitions, or XSDs. Step 3. The payload is strictly validated against these schemas for absolute structural compliance and data typing. If even a single field is out of place, or if a text string is trying to hide where a number should be, Step 4 triggers a hard rejection before the code ever executes. Okay, so what? Why does this actually matter? Because this heavy, uncompromising, strict structural validation is the exact mechanism that prevents corrupted, malformed, or malicious data from infiltrating and destroying mission-critical enterprise systems. When a hospital is updating electronic health records or a global supply chain is routing millions of physical parts, yeah, move fast and break things is absolutely not an option. You need absolute, unshakable data integrity. And XML's rigorous validation guarantees it.
Finally, let's look at Section 5, the Universal Enterprise Bridge.
Let's tie this all back to our initial mystery, right? How do completely disconnected legacy and modern systems communicate? Well, because XML is so incredibly strict, self-descriptive, and platform-independent, it acts as the perfect neutral, decoupled format. It's the absolute foundation for web services, specifically SOAP, that's the Simple Object Access Protocol. It drives enterprise application integration, or EII, cleanly bridging data transfers between 30-year-old legacy backends and modern microservices. And because it's stored as just standard text, literally any system running any operating system or programming language can serialize and parse it natively. When we look really closely at our source material, it leaves us with this powerful realization. XML acts as a universal data bridge across separate, heterogeneous computing systems. JSON might be the fast, flashy courier of the modern web, and we absolutely love it for that, but XML is the foundational infrastructure holding the heavy enterprise world together. So the next time you initiate a seamless, secure transaction between 2 massive institutions, ask yourself, what invisible bridges are quietly carrying your data to safety? Keep learning, stay focused, and I'll catch you in the next explainer.